Now let's say instead of transforming functions, we're asked to transform points on a graph. Well, there is a transformation algorithm, which algorithm is just a fancy name for formula, where we can transform the x separately and then the y separately. If we're translating the x separately, so we're going from x to a new value of x as the graph undergoes transformation, we would say x to x prime. Now, when it comes to the transformation of x or to x prime, the new x value is going to be the old x value divided by the absolute value of b plus or minus the value of c. If we're going to transform the y coordinate of the point, so from y to y prime, then the y prime value, or the new transformed y value, is going to be the value of a multiplied by the old point of y plus or minus the value of d. And so using these, we can transform points on a graph, and often this is probably the best way to accurately transform an entire graph when we know the transformations that it's going through. So let's say we want to calculate the image point on this graph. So for this graph here, the point 1 and 8 is on the graph y is equal to f at x. Give the coordinates of the new point, which would be the image point, given the transformation algorithm. So here we have 3 different transformation algorithms, and we're going to see how that point changes. One of the things that I'm going to do first is I'm going to highlight all the constants that are given, the numbers, and see where they are. Now remember that the a and the d values are outside the bracket. So this 3 over here, that is going to be an a value. Now the b and c are inside the bracket. B is always right next to the x, it's multiplied. And c is either added or subtracted, it's a translation. So that would make this part over here the c. So we're going to do one part at a time for this point. And what we mean by that is that we're going to do the x and the y separately. So we're calculating for the x, will be x prime is equal to x over e plus or minus c, where the x value is 1, as we wrote over here. The b value is 1, the invisible 1 that's right beside the x. And then remember, for the c value, if this is set to 0, then this would actually be a plus 2. So then our x prime value would be 1 plus 2, and that would give us a value of 3. So that's the x value. Now let's do the... So it'll be y prime is equal to, we said that the a value is 3 multiplied by the y value of 8. Now there is no d value, so we'll just write plus 0. And of course that is going to be y prime 24. So the new point here would then be 3 and 24. So this is the new image point of the transformed graph. And what we mean is that this point here, due to these transformations, turns into this point here. So we're going to do the same thing for b here. We're going to highlight all the coefficients here and label them, so we know that anything in front of the bracket or in front of the function is your a, so a is negative 2. And remember that the negative means that there's going to be a reflection along the x-axis. Okay, so we have negative x. So again, this is going to be our b value, which is going to be equal to negative 1. And then the d value is minus 7. Okay, that would mean a translation 7 units down. So we're going to apply the same formulas for the x and the y as we did. So when we apply the x formula, we have 1 over negative 1 plus 0, since there is no c value, and that gives us the x value of negative 1. And then plugging in everything into the y formula here for the y prime, and that's negative 2 times 8 would be negative 16, and the negative 16 minus 7 is going to be minus 23. And so the new point or I should say what 1 and 8 turn into after this algorithm is, or this transformation is done to them, is going to be -1 and -23. Now take a couple of minutes and try C out yourself. Then unpause the video and see if you got the right answer.